Hi everyone, I am Dr. M.Vedaraj, Associate Professor, Department of Computer Science Engineering, RMD Engineering College. Now we are going to discussing about the class diagram. What is class diagram? What is the importance of class diagram? What are the various notations used for drawing a class diagram? The first very important thing, what is class diagram? We already discussed UML as there are two different types of diagram. One is this static diagram, another one is the dynamic diagram. What is class diagram? Class diagram represent the static structure of the system. So its the main purpose, it shows the relationship between various classes, object, attributes and operation. The important, the important of class diagram is it shows the relationship between various classes, objects, attributes and operation. What is the purpose of class diagram? Why do we go for class diagram? Mainly the class diagram is used for analysis and design of static view of application, right? The second important, it's mainly used to describe the what is the responsibilities of the system. The third important thing is it is the base of component and deployment diagram. Okay, so the very important purpose of class diagrams are it is for analysis and design of static view of application. It describes the what is the responsibility of the system. It is the base for component and deployment diagram. Now we are going to discussing about the what are the notations used in class diagram. The very first notation is class notation. See, in UML, the classes are represented in a rectangle box. Okay, see, the rectangle box is divided into three compartments. The top compartment, the top box as name of the class. The middle compartment consists of attributes, or it is also called as the properties and data members. The lower compartment, that is the third compartment, consists of behavior, member function and methods. See, every class in UML is represented as a rectangle box. It consists of three compartments. The top compartment, that is the first compartment, consists of name of the class. The middle compartment consists of attributes or properties or data members of the class. The third compartment is the methods or member functions of the class. See, this is the example. The class is represented as a rectangle box, is divided into three compartments. Here the first compartment, the student, is called as the name of the class. Okay. The second compartment, name, roll number and section, this is called as attributes of the class. The third compartment, display, add, edit, delete, these are called as operations of the class. Okay. The second notation, object notation. See, the object is very similar to classes. The only difference is here the name is underlined. Okay, this is the difference between class and object notation. It's very similar. The object also consists of three compartment. The first compartment is called as the name of the object. The second compartment is called as the attributes. The third compartment is called as the methods. The only difference between the class notation and object notation is here in object notation the name is underlined. That's all. Okay. The third one is called as attributes. What do you mean by attributes? The attributes is nothing but the value of objects is called data value. Okay, the data value of object, the properties of object is called as the attributes. See here the name is the attributes, register number is the attribute, address is the attributes. See, the data values of object, the properties of the object is called as the attributes. This is the visibility, right? Visibility. See, in UML, how the visibility can be represented. So visibility, it is used to define who can access the variable. Okay. See here the different types of visibility we are using in UML. See, the plus symbol represents public. Anyone can access. Minus. Okay. It is called as the private. Only the members can access. Only within a member. Only the members can access. Okay, the subclasses can access. Okay, so this is just you already discuss this visibility access specifier in many programming languages like C++, Java, Python. Okay, how the visibility control, how the access specifiers are denoted in UML. The public can be represented as a plus, the minus can be represented as a private, hash can be represented as a protected. Okay, this is the very important the fundamental UML notations. Okay, public, private and protected. Okay, so how the public visibility can be represented with the help of the plus marker. Okay, how the private can be represented with the help of the minus. Next, the protected is represented as the hash. Okay, public anyone can access, right? Minus only within a class we can access. The protected, the subclasses can also access. This is the association concept. What do you mean by association? See, this is the very important notation used in class diagram. See, the association is nothing but the relationship between the classes, the link between the classes. Okay, see here in this example, what register is one class, the sale is one class. What is the relationship between register and class? Register record the current sale. Okay, so the association represent as a line which is connecting the two classes, right? So what is the relationship between the classes? What is the in this example, what is the relationship between register and sale class? Okay, every sale is recorded in a register, right? So this is the relationship between register and sale class. This is multiplicity, right? Multiplicity is nothing but currently how many objects are connected, right? Asterisk represent many, one dot represent one or more, one dot 40 represent 1 to 40, 5 represent exactly 5 objects are connected, 3, 5, 8 represent exactly 3 objects or 5 objects or 8 objects are connected. Okay, the multiplicity is nothing but how many objects are connected. This is very important. How many objects are connected. Okay, this is the various types of multiplicity we can use in a class diagram. What do you mean by qualified association? This is also one of the very important concept in class diagram. See, the qualified association is nothing but, see, we can select the particular object from the set of objects with the help of the qualifier. Okay, for example, product catalogs, it contain many product specification. Okay, so how can we select the particular product? Okay, with the help of the item ID. See here, the item ID is the qualifier. Okay, so with the help of the qualifier, we are going to select the particular object from the set of object is called as qualified association. The qualifier, we are using the qualifier called as item ID. Okay, with the help of the qualifier, we can select the object from the set of object. Okay, so mainly the qualifier is the term is very important. Okay, so the qualified association is nothing but qualifier which is used to select the particular object. Here the item ID is the qualifier. What do you mean by aggregation? See, aggregation and composition is very important concept when we are discussing the class diagram. The relationship between the child and parent class is represented in aggregation relationship. So mainly you can understand what do you mean by aggregation. See here, the car is the parent class, the passenger is the child class. Okay, the child class can exist independently of the parent class. See, the passenger can exit independently of the parent class. Okay, a passenger may come and go. Okay, so car may have a passenger, they come and go. Okay, so the passenger can exist independently of the parent class. This is called as aggregation. See, the child class cannot depending on the car. Okay, so this is called as aggregation relationship. The relationship between the child and parent class is represented as aggregation relationship, where child class can exist independently of the parent class. A car may have a passenger, they come and go, but the passenger is not completely depending on the car. Okay, it's not depending on the car, it's not depending on the parent class. Okay, so the child class can exist independently of the parent class is called as aggregation. A car can exist without passenger, a passenger can exist car. Okay, so they are not depending. Okay, this is called as aggregation relationship. The next very important relationship is composition relationship. What do you mean by composition relationship? The relationship between child and parent class is represented in composition relationship. See here, the child class cannot exist independently of the parent class. See here, every car has a engine. Without engine, what is the meaning of the car? Okay, so the car cannot exist independent. The car cannot exist independently of the engine. The engine cannot exist independently of the parent class. This is called as composition relationship. The child class cannot exist independently of the parent class is called as composition, right? Every car has a engine. Okay, without engine there is the no meaning for car. Without car, what is the meaning for engine? So they can dependent. Okay, so engine can depending on the car can depending on the engine. This is called as composition relationship. Okay, the next very important relationship, generalization relationship. Okay, generalization relationship, here it shows the relationship between the superclass and subclass. Okay, see, mostly the superclass is more general, the subclass is more specialized concept. Cash payment is the specialized concept of payment. Credit payment is the specialized concept of payment. Check payment is the specialized concept of payment. Okay, so payment is the more general concept. Cash payment is the one of the type of payment. Credit payment is the one of the type of payment. Check payment is the one of the type of payment. So cash payment, credit payment, check payment is more specialized concept. Okay, the payment is the more generalized concept. Okay, generalization is nothing but it show the relationship between the superclass and subclass. Okay, superclass is more general concept, the subclass is the more specialized concept. Okay, so this is the example of class diagram. Here this example is called as the passport automation system. See here, I'm using the different classes. Applicant is the one of the class, passport administrator is the one of the class, regional administrator is one of the class, police is the one of the class. All are connected with the database. Okay, I already told how the classes are represented in UML. In UML, the classes are represented as rectangle boxes. The rectangle boxes is divided into 3 compartments. The first compartment is called as the name of the class. The second compartment is called as the attributes of the class. Third compartment is called as the method of the class. See, the applicant is the name of the class. Name, father name, date of birth, permanent address, temporary address, email, phone number, PAN number, application number, username, password. These all are called as the attributes. Okay, data value of the object. Okay, login, submit details, check status, these all are called as the methods of the class. See, the every class diagram, okay, every class okay, consists of 3 compartments. The first compartment or the topmost compartment is called as the name of the class. The second compartment or middle compartment is called as the attributes of the class. The third compartment is called as the methods of the class. Okay, so today's class we discuss about the what is class diagram. The class diagram is the static view of applications mainly used to represent what is the relationship between various classes, objects and attributes. Okay, then we discuss about the various notations. What are the various notation, how the classes are represented in UML, what is the meaning for association, what is the meaning for multiplicity, what is qualified association, what is attribute. Then we discuss about the what is the difference between the aggregation and composition concept. Okay, that's all about the class diagram, students. Next class we will discuss the another topic. Thank you so much.